One. Hello. Hello. Hi. How it? Yeah. Yeah, hopefully. Hey, how are you doing? Martin, what are you doing over there on the right side? Yeah. Y- Yeah, well, I wanted to up my Twitch game, and you were nice enough to hand me the keys to the kingdom over here. And so we are driving from my machine, which is usually we're driving from your machine, which is pretty fun. So hopefully people can hear me. And oh, we can't hear Martin. Okay, uh, that's not good. Oh, do I need to unmute Martin over here? No, 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 no. Hmm. One moment, please. All right. Martin, you should be coming in on the Ninja, right? Do I just it does not. So let me see. Thanks, Nuno, for the heads up. Let's just see if we can do a quick change here. Give me 1 minute. Um, yeah. Let's see. It looks like it's loading up for me, but hopefully it's loading up for everybody else. You know, Hi, Eric. We're trying to figure some stuff out with the audio here. I think I actually realized what I just did wrong, which is that the audio is not collecting the right thing. Give me 1 second. Thanks, everybody, for... Okay. Okay. Okay.
Okay, here we go. All right. Okay. I'm saying. Oh yes, that's it.
Hi.
There we go.
Hi.
Yep. You can move back to us. There we go. So, hello, Pete. Right then. So, hello everyone in chat. Welcome.
Yeah.
Well, welcome to this. We've gone back to level 1. We're trying something new. So hopefully you can hear me now. Thank you, Nuno, for confirming that. Shall we start from the top there? Hello, Pete. How are you?
Hey, Martin. How are you doing? Well,
I'm good, thanks.
I'm a little, my heart's beating a little bit fast, and that was some on the fly. I feel like, you know, the girl in Jurassic Park who had to hack the Unix machine, you know, but I got it all together. So
Well done. Well done. So we should probably explain. I was gonna say, you know, what have you been up to recently?
yeah. Well, what I've been up to is trying to learn OBS, and so I have been. Thankfully, I have one of the world's best OBS experts at my disposal, and yeah, but yeah, we've been trying to do this for a little bit so I can get myself set up on streaming. I've been streaming on my personal channel, talking about some like product and growth and coding and technology stuff. But when you bring in other people and you try to run it on your own, it's a whole different universe. And so, yeah, Martin, thanks for the heads up, but that's what we've been doing. So yeah, we're streaming from my machine today, which is kind of fun.
Yeah, I think I need to up my game in the OBS tutor department because clearly there was some missteps in all of that. So yeah, I'll brush up those skills.
Yeah, no, well, I think it's all good. I mean, from what I can see, it seems like things are going pretty well. It looks like we've kind of moved your screen a little underneath the chat, so I'll update that in a sec. But minor stuff.
Minor stuff indeed.
Okay. Oh, now my sound and image are slightly async. Okay, I'm not sure what I can do about that, but I'll do my best. So
don't worry about it. That's the advanced class. We'll do that next week.
We just do a quick bandwidth check. I'm not sure. I think the hamsters in my computer are running as fast as they possibly can. So yeah, but Martin, Happy New Year. Good to have you back.
And to you.
Yeah, how have things been going?
Yeah, not bad. You know, it's always a little bit of turbo lag coming back to work after that sort of Christmas New Year period when you're you know, full of food, mince pies and turkey, as is tradition over here. So yes, just starting to come out the other side of Turkey Fest. I think we've only got turkey fritters 2 more times on the menu this week, I believe, and then we're done.
Yeah, we had that with ham on our side. My mom sent us home with so much ham, I wasn't sure what to do with it towards the end. So
right,
wonderful. Well, nice. Well, welcome everybody in chat. Good to see everybody. So thanks for joining on this Friday morning stream. It's nice to Nice to see everybody. Hi, Graham. Hi. Oh, that's Nuno. Yeah, Nuno. Good to see you. Thanks for joining, and good to see you, Eric. Good to see you, everybody, and Monica as well. Oh, Monica named Lex is the girl in Jurassic Park who finds the Unix machine with the graphical interface to unlock the doors in that famous hacking scene. So that is great. So yeah, welcome everybody. So yeah, Martin, what did we want to talk about today?
We're going to talk about best practice, the 5 best security practices for your production-ready containers. So we're going to look at a whole bunch of stuff you can do to ensure that your containers are in tip-top shape for going into production.
Nice.
Specifically from a security point of view, but it does touch on way back when we started with our 101 containers workshops, because it starts with just container best practice and sort of then builds from there. And we're going to look at the bits that build on top of that best practice.
Yeah, wonderful. And I think a lot of these are sort of things that, like, the very first kind of SlimDevOps platform, like we put those insights, like the, that overview page for the containers, like what is the container running as? Is it running as root? What, what does it have in it? Like shells and files with special permissions and all that kind of stuff. And so these kind of simple best practices make it easy to, it's like, this is kind of the baseline of what you should do. And if you just do these things, maybe combine it with the Slim hardening process. But if you just do these things, then you're in pretty good shape from a security perspective. Yeah,
indeed. And what we're going to do is we're going to highlight some myths of container composition and dispel them. So we're going to do some myth busting today as well.
All right. I didn't know I'd dress up as my Mythbusters folks, but awesome. And hi, welcome, Pyrus Masquerade. Good to see you. Best of the best are here, of course. Yep. And Monica says she introduced some American friends to mince pies this holiday season, and it was great. Yeah. Hard to find a mince pie here in the States, I think.
Oh, really? Oh, yeah. Well, I think the British Isles is made of mince pies about this time of year. Or at least I feel like I was made out of mince pies after the
like 80% mince pie at this point.
Yeah.
I saw one. It might be trending though over here, because I saw one in Rhode Island. I live in Boston, and I was down in Rhode Island, and they were advertising mince pies over the holidays at one of the grocery stores. And so maybe there's a little bit of a trend. Maybe it's like hot on TikTok or something, mince pies.
So before we get into this, I've just noticed something, which is some news, which we should probably convey because it's community news. And that's that beneath me is a rotating banner of things. And one of those banner of things says Docker Slim.
Oh my gosh.
And actually, just a couple of days ago, Docker Slim has been renamed and rebranded.
Yeah.
So do you want to tell us a little bit about that, Pete?
Yeah, thanks I can't believe that slipped. In all the audio OBS learning, I completely forgot that's kind of our biggest piece of news. Yeah, we have to update that. So yeah, I can pop a link in the chat here. But yeah, so we renamed Slim Docker Slim, which is the open source project that our company's founded on. And we decided to change the name to Slim Toolkit. A lot of good reasons for this, and our CTO and kind of the creator of Docker Slim, Kyle Quest, we should have him on the stream here sometime soon, has done a blog post about it. The idea, I'll actually put the blog post in the chat, and then people can find the kind of the reasoning behind it and all of that. But oh, oops, hold on one second. I'll pop that in. I think the thinking was the tool's been evolving, right? The cloud native landscape has been evolving a lot, right? And so, when Kyle created Docker Slim back in 2016, like Kubernetes had been out for like a year, Docker had only been out for a couple years, 2015. And so calling the tool Docker Slim made sense because it was like Docker containers, and it still runs with Docker, it still works with Docker containers, but we've added more tools and functionality. The container landscape has kind of grown and changed and been different, and we still work with Docker all the time. We, try to work with all the Docker captains and all of that, but it just made sense to kind of rename it so that, like we could be clear that this tool is just meant to work with any OCI compliant container. If you choose to build your containers another way that's not Docker, we don't always recommend that, but we still think Docker is the best way to do it. But if you choose to do that, you can. And I think one of the biggest things was in KubeCon Europe last year. Ivan Velechko, who a lot of you guys know, who is on staff with us and is a great kind of developer advocate, content creator. He and Kyle led this hackathon that added a debugging capability to Slim containers that is now part of the project, and it actually works in Kubernetes, so it's actually not even kind of like running with the Docker daemon, stuff like that. So there's a lot happening. We're kind of trying to pull the open source project closer to the cloud native computing foundation landscape, and with that, the name change made sense. So we'll have to update all of these, but yeah, you can find the link in this blog post that I just posted, and slimtoolkit.org will be the new website. We've already moved the GitHub repo and all of that. So pretty big news there. And we got to update our screens here. That'll be for another time. So yeah.
I just saw it and I thought, oh, here's some news we should probably tell people about.
Yeah.
So there we go. And Nuno quite rightly points out, as Pete's just described, whilst Docker is a big part of what we do and what we integrate with, it's not the only story anymore, and we need to reflect that.
Yeah. I would say Docker containers is like Docker because mostly, just like we're 80% mince pies over the holidays, Docker containers are 80%. But for those people that are trying other things, and I think we're going to try to like test out a few of the newer kind of container build types of approaches just to see what they're about on stream. I know AWS did a thing with Finch, which is built on Lima, and NerdCuddle, which is just kind of a cool, new, interesting way. I was playing around with it over the holidays. So that's something, if you want an alternative to, Docker, you could use that. Podman has been a long-term alternative to Docker. I think we're still Docker people here. We have our Docker desktop extension, really like that. That's gotten a lot of really good feedback. The Docker company has been a really good partner for us. So, by no means are we signaling that we're moving away from Docker. We just wanted to kind of put the open source in a more neutral territory for people who are building their containers in a different way. And Rancher desktop, of course. Yeah, Rancher, awesome tooling. So, yeah, Nuno, I know you know a few things about that. So, cool.
Yes. Right. Well, shall we get into this?
Yeah, why don't we jump in? Here's our first test of the new broadcasting system.
There we go.
Hey.
Well, that all worked, didn't it? So here's the blog post. I tell you what, I'll put a link to that in the chat so you can read along. And I've got a couple of bits here. So this is a blog post, as you can tell. So you can read through this, and I'm going to sort of give the practical explanation as to what this is all about. So I'm not going to read this out verbatim. There's an exercise for the viewer to read this after the fact. So let's start at the top here. We're going to take a sample application. We're going to look at several techniques to compose that application in a container with a particular focus on security. So let's just do that, starting with here. Let's remind myself of my setup. So let's take a look at this one. Here we go. Let's choose a good example, because those lazy ones are kind of poorly composed. So here's a Docker file. In fact, let's do, instead of less, let's do cat that. There we go. We've got some syntax highlighting going on. So there's some basic best practice going on in this Docker file. So our application is a Python application. It's a very simple RESTful API. And we're going to pin our Python version here. We're using the Slim container. Slim is also a sort of a suffix you see on a lot of community maintained container images to denote that or designate the versions of the containers where they've made an effort to optimize the container size. And the bullseye here is a clue to what base image this is based on. This is using a Debian base image. And then we've got some updates that we're applying. We'll talk a little bit more about that in a bit more detail later. But we're cleaning up after ourselves as well, so we're not polluting the layer caches too much. We specify a working directory. We only copy in exactly what's required, and we also minimize the copy steps here by changing the ownership of those files in a single step. Again, this is to optimize the use of layer caching. We install our Python requirements, and again, avoid polluting the layer cache by not caching that pip process. And then we copy our application in. And then this is really the important piece here. We specify that the user that will run in the context of this container is the nobody account. And this is an unprivileged user account that exists on just about every distribution stroke base container image that you can build on. And it means that your application isn't running as root. Now, this is important because, well, we'll get to the importance of that a little bit later on. We expose the port that we need. That's just, common practice. And then we use an entry point here, and that's so that we have good signal handling, so we can start and stop the container cleanly. So this is all sort of container best practice. So if we shuffle back to our blog here,
To be clear, nobody doesn't mean that nobody's going to use this container, right? It means that it's running as nobody, and that nobody account is provided by Debian. Is that right?
That's right. Yes, this is a Debian-based image, and if we just take a look, what you'll see is that I actually have a bunch of Docker files here, and we've got the same application inside a container image. Again, it's an official Python image, but this one's using Alpine, and it's following exactly the same best practice, but in the way that you would do this for Alpine. And then, we have another one here, which is Distroless, which is a little bit more interesting because this is a multi-part container, but it's the same same best practice techniques applied using different container composition approaches. So this is what we have. So we've got our Python app inside a Python official container, an Ubuntu container, and so on. And we'll just take a little look at these different approaches. So we've talked here about never use or always use an unprivileged account to run your container. It should almost certainly not be the case. You need to run as root. One of the reasons that you do this is if you're shipping your container into production and it's internet facing and it's running as root, and there is an unfortunate bug in your application and that container gets compromised, well, now the would-be attacker lands inside your container with the root context. So they can either disrupt that container, or worse still, if you haven't optimized or hardened the container, they now have a richly instrumented environment which they can run that tooling as root and potentially use that container to disrupt your operations in the rest of your sort of container infrastructure. So they can at best cause a denial of service by messing with your infrastructure. At worst, they compromise sensitive information.
Right, and that's what people kind of commonly call island hopping, and that might start from, like, if you're root and you have dev tools in there, or curl or something like that, maybe you could go out to the internet and pull something in. If you have other networked containers, you can maybe break out of the container and get elsewhere in the Kubernetes pod or whatever you're running.
Exactly. And we've seen some interesting uses of Slim Toolkit and the Slim.AI SaaS platform, because we've spoken to people at KubeCon where they don't want to jump from a unoptimized container to a highly hardened optimized container in one step. So they're using Slim Toolkit or the Slim SaaS platform as like a policy tool.
Yep.
So just using the include and exclude capability to basically say, take our container, but exclude the shells and curl and any test dev and QA tooling that they may have in their, development, fast moving, iterative containers that they don't want to ship into production. So they remove all of that infra tooling out of their containers that they ship to production without going to turn it up to 11 optimization and hardening all at once. So we talked about version pinning. We've talked about that at length on this, on these streams in the past. I think that's well understood why you would want to do this. We're going to talk a little bit about why pinning versions, and specifically why pinning to distro versions are different things. So what we're doing here is we're pinning our language, in this case Python, to a known version. The advantage here is you won't get any unexpected uplifts to your language that's running your application. So you won't get flag day changes where Python 3.10 or 3.11 or 3.12 is released, which may well have either breaking changes for your application or, more likely, a breaking change in one of your dependencies because you haven't been keeping your dependencies in step with, Python changes. So this means that the unchanging language environment. Now, Bullseye means a Debian release. And we'll now talk about, why we do this piece here. Why are we doing upgrades and updates? We'll poke into that in a little bit more detail. But this is something that you should absolutely be doing. It used to be advocated that you don't apply your updates inside your container construction processes, but that's almost always bad advice these days, and we'll dig into that in just a little bit.
Cool.
So we've got the optimization piece, and let's just think about this for a minute. So let's come back here. One of the key pieces here is when you pin to a version in a distro and you don't do the updates, you may well enter a situation where updates have been published by the project, either the base image or the language base image or the just production container that you're using, that you're not pulling in at build time. So an example of this is something like Ubuntu, for example, where they will push out security updates at a fast cadence. At the moment, the last metrics I saw from Canonical were that all high and critical vulnerabilities had fixes available in the archives within 24 hours of the CVE embargo being lifted. So if you're not rebuilding your container images and applying the updates, what can happen is the container image may be lagging behind the updates that are available in the package repository.
Right.
So you always want to apply these updates in order to ensure you do have those updates available in your containers that you're shipping to production.
And the previous thinking that you alluded to is basically saying that, like if you do these updates, then you're not going to have like I don't know if reproducible build is the right word for it, but you're not going to have the exact same container, right? If something in your container gets updated through apt or through this process, then the container that you built yesterday is not going to be the same as the container that you built today, which could be a breaking change. But if you don't do that, then you're not getting these security updates, and you'd rather have the security updates at the risk of the container potentially changing.
Yes, indeed. What you're doing, so there's a distinction. This is sort of a subtle point that's growing in meaning. When you use something like Debian or Ubuntu or one of the RHEL-based distros or even Alpine, when you pin the versions, you've really got a repeatable build. You don't have a reproducible build because again, I could compose this Docker file and I could send it to you, and hours later you could build a container using that Docker file. It will repeat those imperative steps, but your Docker file, your Docker image that's created could indeed be different from mine, because there could well have been updates that have
Right,
changed
right.
in the intervening period.
Mm-hmm.
But yes, it's definitely repeatable, and we've mitigated the amount of change that we're going to see inside that container image as a result. So there is some expectation of the behavior and what should and shouldn't happen.
Yeah, sounds good. Well, just that sounds good. Just wanted to take a second to say hi to KW Samir. Welcome, first time chatter. So yeah, welcome to Slim.AI. We're a company that's built on the Slim Toolkit open source project, trying to stay on brand here, and a group of container enthusiasts. We love talking about container security, building Docker containers, optimizing Docker containers. We're going through our 5 best security practices for containers right now. And yeah, if you like the content, give a follow. If there are new people joining, feel free to say hi in chat. And I want to say hi to Big Pod, who's just dropping in for a minute to join the stream before getting off to work. So yeah, hi Big Pod.
Yeah. So by pinning the distro version and the language version, you're basically ensuring that the updates that you do apply in the container composition process are focused on security fixes and critical bug fixes.
Mm-hmm.
So we rely on layer caching in order to optimize build time and what have you. And this can actually introduce a vector for shipping insecure containers into production, because those layer caches are defined by the lines in the Docker file. So let's just go and take a quick look at one of these Docker files again. Let's go back to the top example one here.
KW Smear says, good. I work on containers and container images. That's awesome. What kind of container images do you work on? Let us know in chat. Love to hear more about that. So,
yes, we definitely would. So the copy command, the run command, for example, if this string does not change, then the last time that the string changed is the layer cache that's associated with it, and that will be reused. So it's not what this does, but the one time it did it, what did it create? And that's the cache that gets used. So every time, so we've done this once. If I run the build on my machine every day for 100 days, this update process is going to be 100 days old, because it was cached once. So we need to be mindful of this, and we need to think about when we need to flush the caches for our build processes. And again, things like the copy process are the same. If the string that follows the copy line doesn't change, the layer cache is unchanged on our local build. So we need to think about that, and we can overcome this through some policy. So what we talk about here is having 2 build processes. Your day-to-day, just build it, make it as fast as possible, but then you want a second build process that runs in your CI/CD pipelines that do a nightly build. They used to be called sometimes daily builds, that always build from a no cache perspective. And we use the pull and no cache switches in the Docker build pipeline here to basically ensure that we don't depend on any layer caching. The build will take longer, but we know everything is up to date in the subsequent image. And we can then put that image through our integration tests to ensure that everything's still working and functioning.
Cool.
So it's a key part to ensuring optimization doesn't actually degrade the security profile of your container images.
Nice.
So go on, Pete.
Cool. I was just gonna say, KW Smear's one of the fellow Canonical folks in working on Rockcraft and Chisel, which are really cool projects. Yeah, we've talked about those a bit on stream already, haven't we? Yeah.
We have, yes. And in fact, I don't know which team you're in, but I was talking to Gustavo and Valentin in Prague last year. When was that? November, about both those projects. I used to work at Canonical, if you're new there or whatever. So it was good to catch up with what's going on there. And certainly something I want to look at as another composition technique to add to this, because you're going to see some interesting myth busting around container composition, particularly using Ubuntu a little bit later on here.
Nice.
So Docker has integrations with Sneak and Sift to do security scanning and SBOM composition. And we also use the Slim SaaS platform to do the same. Now, one of the advantages of the Slim SaaS platform for doing that, if I just switch over here, I've logged in. You can do the same. If you go to Slim.AI, the URL above our heads, there's a Get Started link. You can authenticate with GitHub and GitLab and start poking around with your public container images or connect your private registries. We'll take a look at this image here, I think. Let's take a look at...
yeah. So while you're looking at that, it looks like...
this one.
KW Smear says, Gustavo is my manager and Valentin is my product manager. I joined in September. And then Monica mentioned that Valentin has a good video of OSS Europe. Looks like KW Smear's trying to post the link in chat. Tell you what, so above our head at Slim.AI, there's also a link to our Discord channel. So if people want to drop into the Discord, I'll find the link and drop it in there. Or if Monica, you want to paste it into the Discord channel, I'll pop it over into the chat quickly. But yeah, join us in Discord and we can keep the conversation going. I think we'd love to do a demo of Chisel at some point on the stream. I know a lot of people have been asking about it, so it's a super cool one. So
yeah, indeed. So I've just picked, I rebuilt these container images a little bit earlier and pushed them up to my public Docker Hub. This is our simple example app, but this is the sort of thing that we can do here. And you'll notice that you can see gripe and trivia being used here. And what you see is a security assessment of this container that I just built. But it normalizes the data that comes from both these scanning engines, so you can see what the situation looks like. So, this is another great way to get insight into what's inside your containers. If I just switch back to the piece here. So by looking at this, I composed all of these containers. So if we just do Docker images here, we can see I have a whole bunch of these, but let's just grep these out let's get rid of -v. Let's get rid of my username, which should grep out the published ones. So what you can see here is this image here is the one that we made with Ubuntu. And also what we had to do with Ubuntu is, because Python's not installed in the base image by default, we had to add Python. And then we can see the relative container sizes. So if I also grep out, there we go. We can now see sort of a rundown of like some of the container sizes. So I've got some examples of like what people do and what you end up with. So here we had a tag here, Python lazy. So this actually uses the official Python latest image and it just consumes that whole thing. It doesn't look to do any optimization, and consequently we end up with a nearly 1 gigabyte image for our very simple application. And then we did the same with Ubuntu. We didn't do any optimization with Ubuntu. We just threw everything at that container image that we needed. And then this is where we used our best practice approach, where we, and I'll get to this, we didn't install recommended packages and we cleaned up our cache layers and all that rest of it. So you can see here the Python, the official Python image, our application now weighs in at 161 megabytes as opposed to nearly a gigabyte, and Ubuntu's come down to 131. But we really see some small container sizes here for Alpine and Distroless. And this is where sort of you have this common recommendation that if you want to make secure containers, they need to be small, and therefore if containers need to be small, you need to be looking at Alpine and Distroless. So certainly they're small, but what we need to determine now is, are they secure? What does their security profile look like? So that's what we'll be taking a look at now. But as you can see, when I ran this previously, these container sizes were slightly different, and they
Yep.
do change fairly frequently because of these updates that I was explaining. You know, you
Yep.
apply updates and stuff changes. So we can't deny the Alpine image is certainly the smallest, and so it should be the most secure. At least that's what it tells us. And subsequently, the distroless container should also be secure as well.
Mhm.
So this was how we built our container images, and I think I had the lazy tag in here. So we had jammy lazy here, 429 megabytes, and without the lazy tag, it was 131. And this illustrates here what we did. So when we installed Python, which we needed on that Ubuntu base image, because the other images that we're using, we're building on, have Python built into them, we chose to install Python without the recommended packages. So what we're doing here is minimizing the number of packages that go into our container base image. And again, what we're doing there is reducing the potential attack surface of our container by not shipping into production the things that we don't require.
Yep.
So this is how we ended up with our list of 4 things here,
Yep.
where, you know, our Python image based on Alpine is looking small, and our Ubuntu image is about twice the size.
Yep.
So when we look at that, we should see that these smaller images are the most secure. Well, if we run the container vulnerability analysis, which you can now go and do for yourself using the Slim SaaS platform, as I just showed you, this is what we see. And certainly these Alpine results are excellent. We
Mhm.
see 0 vulnerabilities, and that's great. And then we see this, and this is where it starts to get a little bit confusing, because the distroless container, oh, this table's wrong. I need to edit that. This distroless container has 24 vulnerabilities. These numbers are wonky. I might have to. I tell you what I'll do. I'll switch to here, and
Mhm.
I'll bring up the numbers here. I'll go and fix those after the fact. So let's take a look at this slide here.
Mhm.
Gosh, hang on a minute. Oh, my source material has a bug in it. Okay, no, here we go. These
Yeah.
have got transposed. So we're now looking at the Ubuntu image, which was the 3rd largest, coming out as the container that has the 2nd best security profile.
Yep.
And it has 24 vulnerabilities, but none of them are critical or high vulnerabilities. These are vulnerabilities that are medium or low. And what's interesting here is when you look at the commercially backed distributions that have full-time security teams, they have SLAs, and so you can look at the RHEL containers and things like Oracle and
Mhm.
OpenSUSE, or rather SUSE, and what you'll see is their SLAs will mitigate critical and high vulnerabilities in packages within a short amount of time. So consequently, the security profile of those base images built on top of those distributions tends to be better by some significant margin than those base images built
Yep.
on community-led projects such as Debian. And what we see here is that the Debian image, which is only a fraction bigger than the Ubuntu image,
Mhm.
has 4 times the vulnerabilities and critical and high vulnerabilities in there as well. But then we see this distroless, which a lot of people advocate for as being a small, secure starting point. And actually has twice as many vulnerabilities as Ubuntu,
Hmm.
with critical and high vulnerabilities. And the reason for that is that that is in itself based on the Debian image.
Hmm.
Even though it's a multi-stage build, it's still composed from Debian packages. And some of these critical and high vulnerabilities that are in here, if you go and look at the security reports, and I encourage you to, go and do this using the Slim SaaS platform, because it really makes it easy to dig into these security assessments, you'll find some of these are marked as won't fix
Hmm.
in the Debian project, which means for that release of Debian, there are no plans to actually resolve that security issue in that release.
Yep.
It's fixed in either the next release or the in development release, what's known as unstable or
Right.
SID.
And like, just to double click on that a little bit, like, what would cause a CVE or something like that to be don't fix? And then follow-up question, like, why would, like, how would Ubuntu or Canonical, who's kind of managing Ubuntu, how would they go about fixing? Would they just remove that package, not use that package? Would they have their security team go fix it themselves? I'm just kind of curious, like, what happens under the hood, like, for these, like, won't fix? Because as a developer, it's kind of like, you find it, it's like won't fix. It's kind of like, dang,
Yeah.
like, what do I do? So.
It usually means that in the case of a won't fix, it usually means that the package maintainer, the individual who gives their free time freely
Yep.
in order to update that package, simply doesn't have the time to go back and apply the patches
Mm-hmm.
or sometimes refactor patches for newer versions of
Mm-hmm.
packages and refactor that and bring it back to an older version of the package that's in that release of, insert the name of the distribution, because that
Yep.
can be a time consuming and complex task.
Yep.
And so the outcome of that is, when you look at the commercially supported distributions, they have large security teams who are experts in all manner of languages and ecosystems, who are paid to have the technical know-how to bring those patches back to older versions of software,
Yep.
but more importantly, validate that those patches don't change, alter, or degrade the expected behavior of
Yep.
the application. So that's what your enterprise support contracts with those commercially backed distributions are really buying. It's those security guarantees and those security promises.
Yeah. Okay. Makes sense. Cool. Okay.
So let's go back to the blog, if I can remember where to go. What am I looking for here?
Tab in your
Oh,
chat.
it's tabs. Yeah.
Yep.
too many places to look for things.
See, you're not lying. It's harder to be a guest on stream than it is to be a host. You just sit here. I didn't know your job was so easy, Martin. You just sit here
Yeah.
and like watch other people bounce around the screen. No. This you're simplifying your usual setup so that we could have done this. So appreciate you rolling with the punches there.
So the text here basically explains what I've just talked us through. But here's where it gets interesting. So we've got Alpine that
Yep.
looks like a clear winner because it has no vulnerabilities of any sort whatsoever. So that's game over, right? That's the end of the recommendation process. And this is where Alpine gets so much sort of positive recommendation, because it's small and it's secure. But here's the rub: Python, Node, and many other languages can result in significantly slower builds when you're using Alpine, and that's because they don't have the language archives, like what you install via pip or npm or Ruby gems, don't necessarily have the pre-cached binary builds for Alpine.
Mm-hmm.
So the builds can take longer. So that introduces some inefficiency and a little bit of friction, but also Alpine uses an implementation of libc called Muscle, and there are indeed some differences in the way that glibc, which is more common across Linux distributions, works and behaves compared to Muscle. And you can bump into all manner of unexpected performance issues and ABI characteristics that are just different. And so simply switching to Alpine can come with some friction and developer overhead that you may not have anticipated.
Mm-hmm.
And this is why you still see so many people, developers using Ubuntu, because it's ubiquitous and it's well documented
Mm-hmm.
and it's well understood and it's familiar. So that now we find ourselves in this place where Ubuntu has a decent security profile, but it is considerably bigger.
Yeah. Well, I
The
think
the
that's
the, the image is bigger.
Yeah, I think it's one of the interesting things, because like you see a lot of, Alpine's very polarizing for people, right? There are people who just like
Hmm.
love it and it works and they don't understand why some people don't. And then there's some people who are like, and we tend to get a lot of them on stream or joining sort of our channels that are like, I just never want to use it again because I ran into some sort of horrible bug that I didn't know. And I think that's a good debate. It's fine. It's like, it's healthy for us as an ecosystem to understand that. The thing that kind of weirds me out a little bit about a lot of the tutorials that you see is that people will treat them as being exactly the same and they don't highlight these sort of fundamental differences. So even doing something like a multi-stage build where you start with Python latest or an Ubuntu, latest image, and then the second stage of your build, you switch to an Alpine image. It's like you've just
Right.
changed the entire operating system. That's like, I'd be like, I don't know, like going from a Mac to a PC, effectively, and I don't think that that's made clear to very many developers that like that fundamental change is happening. It's just like, oh, okay, cool, you got a smaller image, good, great job.
Yeah.
Yeah.
Yes, and if you've got a team of people that are familiar with insert name of distro that you've been building your containers with
Hmm.
for 6 or 7 years, you don't want to necessarily take on the friction of having to reskill and relearn
Yeah.
and now become expert in some other platform.
Yeah.
So the question is, what if we could have the low complexity of maintaining Ubuntu-based container images, but the security profile that we got from Alpine? So, and what if we can make containers smaller than that Alpine image?
Hmm.
And this is where, our technology shines. So, Slim Toolkit, as now is, or Docker Slim, as it was
It
once known,
was.
or the Slim SaaS platform, can do that minification and hardening
Hmm.
for you. So that's where in my thing here, I had, if I leave just the Slim images in here, these Slim images all went through. In this case, I used Docker Slim. So let's take a look at this. So these are the same images
Hmm.
that we produced that we ran through Docker Slim. And what we find is this: they are all now approximately the same size.
Yeah.
So let's take a little look back in the presentation as to what we've done there. So we used Docker Slim to optimize and harden our original container image. Now, people, whenever we talk about slimming and hardening, people always say, "How does this work?" Now, we're fortunate that Ivan works on our team and he produces these fabulous little explainer diagrams.
Yeah.
So this is it in in as simplified form as is possible. But the original container is executed. Slim, as it's now known, from the Slim toolkit, the command Slim observes that container whilst it's running. It uses some dynamic and static analysis to determine what that container actually requires to operate, and it creates a new container image that
Hmm.
is a single layer container image that only contains the assets from the original that the app actually requires. So it's a massive oversimplification, but that's kind of what's going on there. And so we end up with these smaller container images. Now, there's some security benefits here. We talked about not shipping unnecessary tooling into production. This helps us do that.
Yep.
The shells that we don't need are ejected. The tooling we don't need, like curl, for example, are ejected.
Yeah.
Any dev, test, and QA stuff, all thrown away, not required. And so that leaves us with these much smaller containers.
Yep. And
Um,
Samir's asking, does Docker Slim or the Slim platform also does this? So would it work with a Docker image created with Chisel? And short
it
answer is
does.
yeah, it'll work with any OCI compliant container image. And certainly anything that's created with Docker. I also hear an idea for a stream. I think it would be cool to try and look at what that. Have you tried that, Martin? Have you tried
I have,
slimming
yeah.
Chisel? Okay, cool, nice.
Yeah. Now, chiseled container. I think chiseled containers would be very interesting to take a look at anyway, because
Yeah,
I think it's a very interesting way to compose containers.
yeah,
You get a number of these. Well, you get the security benefits because it's built with Ubuntu, but you also get some size benefits because the whole point of Chisel is it doesn't include the unnecessary stuff that you don't need. But nevertheless, you go a step further when you optimize and harden that container with Slim, because you now eject even more that you don't, that the application doesn't require, because this builds the application intelligence to say, well, yes, whilst I did pull in these very specific library requirements, I didn't actually need all of those libraries for this application to function.
yep, yep,
There are others that we could look at as well.
yeah.
So this is what we end up with. We ended up with these containers going in, the original container sizes, and we end up with this order. So we
Yep.
made our Alpine image 3 times smaller, and we now get this Ubuntu image that is nearly 7 times smaller. But only now we have these optimized containers, which are for Ubuntu, which are only 4 megabytes smaller. 4 megabytes larger than an optimized Alpine image. But this Ubuntu image, this minified hardened image, is about half the size of a regular Alpine image.
Yep.
So you've got none of that developer friction coming in, but you get all of the benefits of having all of that extra stuff removed. And what we actually found is when we went on to look at this image, and in fact this image, the Python image. Oh, my headset's about to fail. I will get another one. We had no vulnerabilities in the minified container.
Yeah.
I'll leave this as it is for the moment in the hope that it doesn't die on me.
Yeah. So to talk through this with people, right? So like what we've done is we've removed some of the parts of the operating system, parts of the libraries or packages that were pulled in that the system determined were not required. In doing that, removes a lot of the vulnerabilities that were from, libraries that it turns out were not being used. And Alpine is still slightly smaller than, say, one of the Ubuntu or Debian based images, just because, it's probably using, I don't know, Musel-C or, something like that might be smaller than glibc. There are still differences in the operating systems, but the size difference and the sort of number of files and complexity there is much reduced, and they're much closer together once you run them through Slim Toolkit or the Slim platform. So
Indeed.
yeah.
Indeed. So, this is a great example of where you can have your cake and eat it too.
Yeah.
You can stick with Ubuntu, you get Alpine, smaller images than Alpine with no vulnerabilities whatsoever.
Awesome. And yeah, Samir, it looks like, if you want to do a Chisel Slim mashup on stream with us sometimes, I'll reach out to you on Discord, but that sounds really great. We'd love to. We have a very Ubuntu and Canonical friendly crew here. A lot of our folks have been through Canonical. And so, it would be great to get the two teams together. So,
absolutely.
in fact, I think it would be kind of fun to kind of like look at some of these like new and innovative things that are coming out. There's Chisel, there's Finch that I mentioned with AWS, and sort of that's based on some things called Nerdcuddle and Lima, which is kind of new container tools. There's kind of Acorn and ChainGuard have some interesting new kind of base images and or container building approaches. So there's a lot of cool stuff happening in kind of the container space all of a sudden. So yeah.
So there we go. That was my show and tell. And I suppose what we were really highlighting there is, you can have some very interesting starting.
Hmm.
Choosing your starting point for your container composition can have a significant impact on the security profile of the container that you end up creating.
Yep.
And don't just follow the sort of the recommendations blindly.
Hmm.
Actually do an exercise like this. Take your application, use different container
Hmm.
composition techniques. Do you introduce any unexpected behaviors? Does your application work correctly? Do you get any benefits? And then take a look at Slim in order to take that to the next level,
Hmm.
either through policy enforcement, removing tooling that you don't need, or really go for it and harden that image to the next level and really optimize, because you also get benefits with hardened images because they're single layer, there's fewer files, so they deploy and start faster as well.
Yeah. Okay. Yeah, absolutely. Lots of great benefits there. So cool. All right. That's a really great demo. Do we have anything else to share, or does that kind of wrap up your five best?
That sort of wraps it up. Yeah, I think we
Cool.
had. I think the outcomes are there are sort of more than five things, but
Yeah.
the conclusions are here, and it's really pointing out to people that there are ways to find optimizations and security benefits, particularly in a climate where there is a drive towards no known vulnerabilities in productions that are shipping to container, shipping as containers. um, you can do a lot of work, manually up front to adhere to container best practice, but even that isn't sufficient, and you can use some automation to really, iron out the rest of the issues that you're facing, particularly if you're on a drive. One of the things that we can do here in the platform, I showed you that view. Let's choose Distroless this time, where you can look at the vulnerabilities. Well, if you're pushing this container multiple revisions through CI/CD, let's say multiple revisions a day, multiple revisions a week, this vulnerability report will actually trend over time.
Yep.
So you can see the changes in the number of vulnerabilities, which vulnerabilities were added and removed. If you're reporting to a client, um, we're working to get the vulnerabilities in our containers down, and they currently know that there are 20 vulnerabilities, and 4 days later gleefully tell them we have eradicated 3 vulnerabilities from our containers,
Hmm.
but the overall number is still 20
Right.
because
Right.
new
Right. Right.
vulnerabilities have
Right.
cropped up. At
Right.
least you can demonstrate you have removed these 3,
Right. Right.
but due to the progress of time, there are 3 new ones you need to deal
Yeah,
with,
and I think
and it's
Aisha and
actually
our
doing a
team has a stat that for every one that's remediated for kind of the popular community images, 4 new ones show up. So I think that's good, right? That means that as a security ecosystem, as a security industry, we're doing our job of finding vulnerabilities, reporting on them, getting them into the
yeah,
databases. But if you think that this is just happening because some community maintainer in Nebraska is patching those vulnerabilities as soon as they find them and on high alert, it might not necessarily be the case. Those maintainers, God bless them, are very busy and volunteering their time and all of that kind of stuff. So you have to kind of be responsible for your own vulnerabilities, and this helps you kind of get focus on just the ones that you need. So
indeed.
yeah.
And I think that one of the issues with a report like this is it has been used as a stick. Here
Yeah.
are all of the things you need to fix, and what we're doing differently here is we're not just producing a stick with which to beat the DevSecOps department,
Right.
because if you then put these containers through the hardening process, which by and large is automatic,
Hmm.
you actually get a report out the other side, which is the vulnerability reduction
Yeah.
as a result of doing that. So now you know what the transformation was and what the benefits were.
Yeah, and importantly, right, not just the vulnerabilities, but as you highlight in this blog post, like all of the attack surface, right? The shells, the package managers, the curl, dev tools and stuff like that can be used. Like they wouldn't come up as vulnerabilities. Curl's not inherently
Right.
vulnerable. It might have a vulnerability associated to it, but it can still be used to pull in malicious code. And so you don't want it in production because generally you don't need curl in production. You need it as you're doing
Right.
development. So yeah, a lot of important stuff
Yeah.
there.
Yeah.
Cool.
Indeed.
Okay. Well, awesome. Well, thank you for sharing that. That's a great talk, and I know you've been given that talk and had that on the blog post. Um, I'm not ready for the next section, Martin. I want to say that I am not ready. This is a hard thing. So I guess there is a reason that we are kind of transitioning the hosting duties. And do you want to let people know what that is?
Sure. So I'm going to be leaving Slim, and there's not much time left, unfortunately,
I
because of the
know.
holiday period. So I'm going to be leaving next week, in fact, at this point. So next week's stream will be my last one here as a Team Slim member.
I know, Samir. No, why? I know. I'm very sad, Martin. I've learned so much from you. I mean, I've had so much fun on all of these streams, and I just can't. Even just now, as you were going through all that, I'm like, oh my gosh, how are we going to do this without you? So, but I understand. I definitely understand why, and I wish you all the best. So, yeah, we'll do something special for next week's farewell Twitch stream. Maybe we'll do. In the back of my mind, what I have is a clip show, like the classic '80s clip
Oh
show.
no, please no.
So we'll see. We'll see if we can make that happen from our 2 year. But it's been 2 years that you've been with us at Slim. I think you and I joined at about the same time. So yeah, I
Yeah.
just want to say wish you luck, and we'll get all sappy and cry and sad
Yeah.
tea next week.
But nowhere's far away in this industry. I'm
Yeah.
sure our paths will cross again, and with the rest of the community as well. I'm sure we'll bump into each other at different events around the world.
Yep.
And as for coming back to Canonical, no, I'm not going to be returning to Canonical, although I probably will see lots of my friends from the Ubuntu community at various, Ubuntu and open source events over the years ahead, not least at the Ubuntu Summit, which now is scheduled to be an annual event. So,
Awesome.
We'll see people.
Yeah, well, and just want to say, obviously you're welcome to, and hope you do kind of stay in our orbit, the Slim community. You've really helped build up a great, healthy Discord community that we have. This Twitch stream, I just looking at it now, we're almost at 500 followers, and that's all the work that you've done since you've been here. So expect some raids from us on your own channel over at Wimpy's World. Expect maybe a PS Van to drop in and ask you to do some OBS streaming from time to time, so you can I don't know, teach me about audio, different stuff. But yeah, no, we won't be far away. So just want to say a big
Indeed.
thank you, and we'll break out the sad music, the sad stream beats next week, and all of that. But yeah, I just want to say thanks for everything. So
Well, likewise, it's been an amazing time at Slim, and I've thoroughly enjoyed it.
awesome. Okay. All right. Well, with that, I want to say thanks everybody for joining the stream. Samir, great chatting with you. Give us a follow. We'll talk to you on Discord and try out that chisel stuff. For other people who are joining, if you go to Slim.AI here, you can find our Discord channel. You can follow us on Twitter. I am at PSVANN on Twitter. Martin, where can people find you?
Oh, that's a good question. Oh, Wimpress.com, I suppose.
Okay.
I dusted off an old
Nice.
website.
Like it.
So yeah, Wimpress.com is got at the bottom of that website a whole bunch of icons to find me on Twitter and Mastodon and
Yeah.
LinkedIn and GitHub and all of those things. Even Launchpad. There we go.
Wow. I'm gonna have to update my where to find me stuff, because I think Twitter is maybe people are not doing Twitter as much anymore. So
Yeah, I've seen a lot of people saying I'm not going to be posting here so much this year, and lots of activity on Mastodon.
yeah.
So if you're looking for a Mastodon instance, Hackyderm that's run by Chris Nova is a good place to land, and also Fostodon is
Awesome.
another great place to go.
Okay. Well, that is amazing. Actually, you want to try? Do we have the skills to raid? because I actually see Chris Nova is
Oh,
on right now. Should we raid
right.
Chris Nova?
Yes.
All
Yeah, we
right.
should totally do that.
Cool. How do we? So I have I'm in Twitch and I have the raid channel. Pick a live channel to raid. Can I just type in Chris Nova
Yep.
here? All
Yep.
right. And we are going to raid Chris Nova, and we will start
Awesome.
the raid, and we'll see how that goes. Cool. Um, all right. And so, yeah, thank you, everybody. And we will see you over on Chris Nova's channel. Thanks again, everybody, for joining, and see you next week. So,
See you next week. Bye for now.
all right. Bye-bye.